So here's the theorem there that I was just using with that circle thing. If it is even, then the integral from negative a to a is 2 times from 0 to a. But if it's odd, then from negative a to a, it's just 0. So somehow I still don't feel like that's right. I think I'm going to work this one on the board just one more time. Pi a squared minus x squared. So the integral from negative a to a of pi times a squared plus x squared. I'm going to integrate that, pull out the pi out here, negative a to a, and I'll have a squared plus one third x cubed. Alright, so then I'll have pi a squared plus pi 1/3 x cubed from a to negative a. So I'm going to plug in a. Pi a squared. Where's the x? There's an x somewhere in there. Where did that come from? I don't understand where the x came from. I just don't get it, where that x came from. Pi a squared x. Integrate that a. Somehow there's an x that pops in there. So plug in a. Pi a to the 3 plus pi 1/3 a to the 3 minus, and then I'll do pi minus negative pi a to the 3 plus minus pi 1/3 a to the 3. So I'm subtracting that. So it's going to be pi a to the 3 plus pi 1/3 a to the 3 plus pi a to the 3 plus pi 1/3 a to the 3. So I'll add those together and get 2 pi 1/3. Can I just add those together? 2 pi 1/3 a to the 3 over 2 pi 1/3 a to the 3. So adding those together, so I'll get 4 pi 2 pi plus 2 pi is 4 pi 1/3 a to the 3. 4 over 3 pi a to the 3. Alright, so I guess that theorem didn't need it, and I did get the right answer. So that was kind of crazy there. I don't know if you can see that or what. That was crazy. That was pretty crazy. Okay, example 6. Maybe if I could lift this up a bit. Hope this works. I don't think this is gonna work. Doesn't look very stable. I have a feeling that's gonna fall over. Okay, axis. Okay, there it goes. It's falling. I probably should put that on a bowl. Whatever. I'll just read it. Axis of revolution in the next example is not the x-axis, but the rule for calculating the volume is the same. Integrate pi radius squared between appropriate limits. Example 6. Find the volume of the solid generated by revolving the region bounded by y equals the square root of x and the lines y equals 1, x equals 4, y equals 1, x equals 4, and the line y equals 1. Alright, so I don't know what's going on here. The lines y equals 1. Alright, so here's the lines y equals 1. Oh, you can't even see. So here's the line. Here's the line y equals 1. X equals 4. And y equals 1. Y equals 1, x equals 4, about the line y equals 1. So it flips around this line right here. And there's one line, there's the other line. Okay. Alright. So I see the visual depiction. The equation is going to be from, like it says there, from 1 to 4. Y equals 1, x equals 4, 1 and 1. Okay. So the radius r of x equals the square root of x minus 1, because y equals square root of x minus 1. 1 to 4 pi. Why is it the square root of x minus 1? So instead of it just being the square root of x, do minus 1. Square root of x. Oh, this is... okay. That right here is the square root of x minus 1. That's where the x minus 1 comes from, because of that red line. Square root of x minus 1. And I'm gonna get something to put that thing on. There. Sweet. Okay. Okay. Square root of x minus 1, because it moved up. No, it moved to the right one. Is that... how did it move to the right one? It moved up 1. No, it didn't move up 1. But it moved to the right one. That line right there. For some reason, that's the square root of x minus 1. So from 1 to 4. Alright, so from 1 to 4. Let's do that then. So here's our graph. Whatever. 1, 1. That's where it starts. Shaded. That's where it goes. Rotates about this axis, y equals 1, and y equals x equals 4. Alright, 1 to 4 r of x pi squared. Alright, so integral from 1 to 4 of pi times square root of x minus 1. Do I do that squared? Do I square that? Yes, square that. Alright. So do I use u substitution? No. Dx. So we'll just do 1 over 3 pi. Crap. Do I expand that out? What do I do there? Yeah, expand it. Expand that out. So it'll be x minus 2 square roots of x plus 1 times pi. Alright. Right? Yeah, and then I'll just pi x minus 2 pi square root of x plus pi. All that dx integral from 1 to 4. Just integrate each one of these. It's been a while. Pi over x equals 1 over 2 pi x squared. Oh no. So that's 1/2 minus 4 pi to the 3 over 2 plus 1/2 pi squared. Shoot. Pi x. And from 4 to 1. Golly, that's madness. Oh, you can't even see. That light's like right up in the business. I wonder if I can get a different light. I wonder how I could fix that. Anyways. Alright, so how much of that did I do right? Alright, so pi 1. That one's right. Minus 4 over 3. It's 4 over 3. 4 over 3 plus an x. Not even a pi, just x. Alright. 7 pi over 6. No, I probably should have done that. What do you think? I don't know. Sometimes you have to fix that light. It's right on the board. Maybe I could scoot the camera up and it wouldn't be there. Alright. Let me do that one more time. Let's see if I can film. Dang, I don't think that's gonna work. Man. How's it look now? There, that looks pretty damn good. At least alright. Alright, let's try that again. I'm gonna erase it so I don't even see it. I'm gonna erase everything. Alright. So, my equation is y equals the square root of x. X equals 4, y equals 1. My lines. So x equals 4, y equals 1, 1, 1. Here's the graph, not paying attention there. And then that's where it's going to be spinning about there. We're reaching the area of that. So integrate from 1 to 4. Square root of x plus minus 1 squared times pi dx. Expand out this variable, pull up the pi over here, 1 to 4. X minus 2 square root of x plus 1 dx. Integrating that, we're going to get 1 over x squared over 2 minus, so that's x to the 1/2. No, yeah, raise it to 3/2. X to the 1/2. So 2 minus 2 times 2 minus 4 over 3. X to the 3/2 plus x times pi. Integrate from 4 to 1. So plug in a 4. 16 over 2 is 8 minus 4/3 times 16 cube root of 16. 2 times 2 times 2. Cube root is 16. Cube root is 16. 2 times 2 times 2. 2 to the 3rd power is 8. X to the 3 over 2. X to the 1/2. X to the 3 over 2. Over 2. So 4 squared. Is that right? Is that right? 1/2. No, that's not right. I did that backwards. That's major bummer. Square root of 4 cubed. 81, which is 9. 9 times 4/3. I don't know if that's even right. I need a damn calculator. Plus 4. 4/3 times 9 is 12. 8 minus 12, negative 4 plus 4 is 0. So that's 0 equals 0 minus, at 1, we get 1/2 minus 4/3 plus 1. 1/2 minus 4/3 plus 1. And all that times pi. Hopefully it'll just give us 7 pi over 6. Alright. So that did work. Okay. Back to the book. Region A in a solid of revolution B, example 6. Oh, okay. To find the volume of a solid, generated by revolving a region between the y-axis and the curve. Oh no, x equals r at y. Y is between C and D. Oh no, about the y-axis, we use the same method with x replaced by y. In this case, the circular cross-section is a at y, oh no, equals pi radius squared equals pi radius y squared. Oh, that's bad. That's very bad. A at y. Pi radius squared equals pi r y squared r at y squared. That's not too bad. It's not too bad yet until we get to the next page.
volume by disks for rotation about the y-axis. Find the volume of the solid generated by revolving the region between the y-axis and the curve x equals 2 over y. Y is between 1 and 4 about the y-axis. Volume equals the integral from c to d a at y dy equals from c to d pi r at y squared dy. Okay. Alright. I am in agreement. Y is from 1 to 4. X equals 2y. Alright, let's do this thing.
Oh, that's a permanent marker. That was bad. It was almost really bad. So, from 1 to 4, y is from 1 to 4, and the curve was, what was the curve? X equals 2 over y. So if x equals 2 over y, that's like y equals 2 over x. Huh? Is that right? Well, I guess that's right. So anyways, I'm going to integrate from 1 to 4, 2 over y dy. Alright, it's simple enough. I'll just do, oh, it's like natural log 1 over x integral 1 over x dx ln of x. Right? Because if I take dy dx, the derivative of ln of x, I'll get 1 over x. So ln 2 ln y dy dx oh, there's a squared in there. But does that make a difference? I have to do the squared. And the pi. So from 4 to 1 pi. So I'll take the pi out. From 1 to 4. 4 over y squared dy. Well, how do I integrate that?
4 over y squared dy. Pull out the 4, negative 1 over y.
Pull out the 4. 4 pi 1 to 4. 1 over y squared dy. What? How do I integrate that?
Negative 1 over y. What? 4 pi negative 1 over y. So we get 4 pi integrate 1 to 4 1 over y squared, which is, oh, because it's y squared, y to the negative 2. Alright, it's all good, dy. And I'll just get 4 pi integral from 1 to 4 y to the negative 1 over negative 1. So it'll just be negative 1 over y times 4 pi. 4 pi negative 1 over y from 4 to 1. I'll just plug it in. Right? Simple enough. Next problem. Let's probably do it again. Probably do that one again. I guess I'm not going to. Find the volume of a solid generated by revolving the region between the parabola x equals y squared plus 1, y squared plus 1, and the line x equals 3, about the line x equals 3, and the line x equals 3, about the line x equals 3. So we draw figures showing the region, a typical radius, and the greatest solid. Okay. Find the volume of the solid generated revolving the region between the parabola x squared plus 1, x equals y squared plus 1, and the line x equals 3, about the line x equals 3. X equals 3. Alright. Draw out a figure, typical radius, the generated solid. Cross sections are perpendicular to the line x equals 3 and have y coordinates from negative square root of 2 to square root of 2. So I guess they plugged in 3. Yeah, when x equals 3, can't really see that. When x equals 3, they get positive 2, square root of 2, and negative square root of 2. And the line is, okay, x equals y squared plus 1. I think I got this from here. I hope so. Alrighty. The line x equals y squared. One more time. The line x equals y squared plus 1. Here's our line x equals y squared plus 1. Solve for y. Y equals positive and negative square root of 1 minus x, I think. 2 minus y squared. I guess I shouldn't have even solved for y. Yeah, it's just y squared. So x equals, when x equals 3, and then it's going to be like that and like that. We plug in x equals 3. So 3 equals y squared plus 1. We'll get x equals positive, negative, square root of 2. So those are our limits right here of integration. Negative square root of 2
positive square root of 2. And then our equation, y squared plus 1 squared times pi, and we just integrate. Y to the 4th plus 2y squared plus 1 pi out here, integrate negative square root of 2 to 2. Integrate that bitch. Integrate that bitch. Square root of 2. 1 over 5 y to the 5 plus 2 over 3 y to the 3 plus y times pi. Integral from square root of 2 to negative square root of 2. See how close I got there. Y to the 5th over 5. Alrighty. For y. Okay, looks like I messed up. Negative 4/3. Oh. 2 minus y squared. 2 minus y squared. Where's the 2 minus y squared? Okay. 3 minus y squared plus 1. Gotta take this y squared plus 1 and make it 3 minus, because there's a 3 here. That sucks. This is all scraps. 3 minus y squared plus 1. That's what we're doing there. Integral from negative square root of 2 to 2. Oh, yeah. So, y squared negative y squared plus 2 minus 2 minus 1 minus 2 3 minus 3 minus y squared 3 minus y squared minus y 2 minus y squared. So we get 2 minus y squared squared. And then the same thing I had just done.